Oh, greetings and welcome, friends. We're taking a look at sum and product of roots. Okay, roots are the same as x-intercepts or zeros. We had a couple formulas we learned yesterday, and we're looking at last night's homework, which was on page 363 of our text. And here's problem 23. So if these are my roots, that means S1, S sub 1 is negative 4, and S sub 2 is negative 2/3. So I'm interested in their sum and their product, sum and product of roots. Now the sum of your roots supposedly is equal to negative b over a. And the product of your roots, not just supposedly, but we proved it yesterday in a video, is equal to c over a. So I'm going to add these, multiply these. Yeah, I cough all the time, it's okay. I'm not dying right now.
Smoker?
Never have, never will. But negative 4 plus a negative 2/3, I guess I could write that as minus 2/3. So if I add these together, well, I'm going to need a common denominator. Come on, denominator. Let's see, multiply by 3 over 3 here, sounds good. So I'll get, what, negative 12/3 minus 2/3. Sounds like negative 14/3 to me. And that should equal negative b over a, apparently. The ratio of negative b to a is that. It doesn't guarantee that a equals 3, necessarily. All right. Over here on the other side, let's plug in what we got. We have product, so negative 4 times negative 2/3. To multiply that, well, I could put that over 1 if you want. Negative times a negative is positive. 4 times 2 is 8. 1 times 3 is 3. And that should equal c over a. So analyzing this, let's see if I can figure out a, b, and c. Well, the denominators of these guys are the same. So I'll just call that my a. Why not? Oop, up, oop, up, oop, up. So a is equal to 3. The opposite of b is negative 14, so plain old b must be positive 14, and c is equal to 8. So that means a, one of the infinitely many possible quadratic equations that have those two solutions, would be 3x squared plus 14x plus 8 equals 0. All right, so that is your kind of most basic version of it. Any multiple of this, if you multiply both sides by 7/2, that'll give you another quadratic equation that has the same solutions. Okay, so there's problem 23, not too shabby. Problem 27, a little bit trickier. Let's find their sum and product. So to add them together, S1 plus S2, that'd be negative 2 plus 5i over 4 plus negative 2, I don't know, 23 or something. 23 or something. Let's see. Hey, good news, these have common denominators, so I can combine like terms. Negative 2 and negative 2 is negative 4, if I might say so myself. And 5i and negative 5i, whooshing, whooshing, fruit ninja. So, negative 4 over the common denominator of 4, that reduces to negative 1. If that's going to help us, we'll see. So supposedly that's the ratio of negative b to a. If you want, you could write that over 1 as well if you're a fan. So let's multiply these as well. Doesn't look like I have enough room on the right side. So I'll just write it underneath. So negative 2 plus 5i over 4 multiplied by negative 2 minus 5i over 4. Now for the denominators, 4 times 4 is 16. For the numerators, check it out. What are those? Conjugates. So that means I'm going to use the pattern a squared minus b squared for them. Or you could FOIL it out if you want to take more time. If you're just like really enjoying and savoring the math, you want to just like take the scenic route, go for it. That's fine. I have no problem with that. Negative 2 all squared minus 5i all squared. I'll do a little work over here. I'll keep working vertically. Why not? So 4 minus 25i squared. Wait a minute. What's I squared, friends? Negative 1. So that's the same as 4 minus or plus 25. So that's 29/16. And that should be the ratio of c to a. Now, looking at that and negative b over a was equal to negative 1 over 1. Looking at these two facts that I've just gathered, the a's don't agree with each other. So I'm going to need to find a common denominator in order to get my a's in agreement. What would a common denominator be between 16 and 1?
16.
16. So we'll multiply this fraction by 16 over 16, and I'll get negative 16 sixteenths. So looking at that now, what do you think a should be?
Negative 1.
16.
Kidding, imagine that.
Just kidding. LOLs. Do it for the JKs. So let's see. What would b equal? Well, the opposite of b is equal to negative 16. So b must be plain old vanilla 16. And c is equal to 29. So our answer is 16x squared plus 16x plus 29 equals 0. And that, I believe, is the smallest number, whole number version, integer version of a quadratic. But like I said, any product of that would also work. So, next, I'll come back for those of you still writing later. But for the sake of the internet, let's keep going. Problem 29, the instruction said, solve each equation. Check by using the sum and product of roots. So I can solve this using any way I want. You guys want to try AC method, you want to try completing the square, you want quadratic formula. I could even use the discriminant first, figure out what kind of answers I'll get, and whether or not it's factorable, so I can decide whether or not that technique's one I want to use. What are your thoughts? Ideas?
That's AC.
First thing I'm going to do, I don't like starting with a negative. It'll usually be a little easier if I make the leading term positive. Let's see, let's check AC method. I didn't use the discriminant, so there's no guarantee that it would work. So let's see, 2 times 12 is 24. Factors of 24 that add to be 11 is what I'd be looking for. So 1 and 24, 2 and 12, no. 3 and 8, oh yeah, 4 and 6. So I'll do the classic, of course you guys all remember this, split the b term into two like terms with coefficients of the factors we just found. So I'll have 3x and 8x plus 12 equals 0. What are their signs going to be though is the question. Well, they have to combine to be 11 and multiply, yeah, plus plus, okay. I was worried for a second, I thought I made a mistake. Classic. There we go. There's that ugly 8's a little bit uglier now. So next step, let's GCF the first two terms and the last two terms. This is called factor by grouping. So I take an x out there. I could take a 4x out there. So I'll have x times 2x plus 3 plus 4x because this was positive, right?
You take 4x out of that.
Thank you. 4 out of that. Good call, friends. You got my back.
And then you be able to take 2x. So it's not my half.
Yep, okay.
Oh no.
X plus 3. Oh, wait a minute. Oh, 2x plus 3. Man. All right. I threw my head for a loop here. Hey, my parentheses match, which they had to. Good news. So my answer, well, nope, I lied. My factors are 2x plus 3 and x plus 4. But that is not my answer. To find my answers to the quadratic, I can set each one of these equal to 0 and solve. And solve in time. So I split those up, by the way. So subtract 3, subtract 3, subtract 4, subtract 4. And divide by 2 over here. Hey, it looks like my answers are rational. So if I did do the discriminant, what would I have gotten for a value? What kind of number would it have been? The discriminant would have been a real number, yeah. It would have been a positive number, and it would be a perfect square because my answers are rational, which also verified that it would be originally factorable, which I just factored it, so that would have to be the case. So if those were my answers, and then I was like, but what if I wanted to check this? Well, let's use sum and product of roots. So let's add them. Add them. Negative 3/2 plus negative 4. I'm going to need a common denominator. Multiply by 2 over 2, right? So that's negative 3/2 minus 8/2. Okay, okay. What I'm doing here, by the way, is S1 plus S2, if you're wondering. So that's going to be negative 11/2. Yeah. And that should equal negative b over a, according to our formula. And then let's multiply them. Negative 3/2 times negative 4, right? If I'm doing S1 times S2, right? So negative times a negative is positive. Put that over 1 if you want. 3 times 4 is 12. 2 times 1 is 2. And I won't simplify these just yet because I like the fact that they have the same denominator. So, according to this, what would A equal, B equal, and C equal? Yeah? Yeah? Yeah. So, according to this, a quadratic that works out should be 2x squared plus 11x plus 12 equals 0. And, whoa, glitching. 2x squared plus 11x plus 12 equals 0 is a possible version. Or I could multiply it all by negative 1 and I'd get that as well. So it all worked out. Good news, I can use this as a checking technique, which is kind of cool. Not too shabby. All right, internet friends, thanks for watching. Tienen un día al más bien del mundo. El fin de semana!